product keys to Office and to Visio, which I fixed both my problems, by the way. First of all, I had to uninstall Visio to work with the new. I'm sorry, I had to uninstall. What the hell did I? Oh, I had to uninstall OneNote in order for the new Visio 2024 to install. So then I just, uninstall Office 365 altogether because OneNote by itself wasn't really installed. So I was just like, that's kind of odd. Why would it tell me just to get rid of OneNote? But I did it, so I got rid of the whole thing, and I just upgraded this. But I thought Office was 2024, not 2021, which I really don't care. Okay? But Visio was fixed. Okay? So the first thing we're going to do is we're going to go in here. Visio. Okay? And what does this say? I just put this product key in here. Thank you for installing 2000 activation as required. I want to activate software over the internet. Okay. Alright, that's kind of weird. Alright. I just wasn't expecting that. So anyway, great. Alright, and we are going to start off, which it's like, okay, am I stupid now? Do I have to relearn this software? But apparently not. So let's go to network symbols, okay, and we are going to go like this. Oops. Okay, now we are doing VMware, alright, which is the ESXi server, my favorite. Okay, alright, so the server's running in the background, I can hear it, and it's like a whole new atmosphere in here. It's like, I've gone back in time and reclaimed my life. Which, a year of me not having the things that I need to have on a regular basis, dude, I can do that on top of my head. So now, let's actually go text and G1. Alright, and let's shorten this bad boy up. Okay, and let's make this solid. How do I do that? I don't remember. That's kind of weird. Okay, I guess I'm going up here then. Alright, and oops. Green, which is my favorite color. As far as this is concerned, because green is not my favorite color by a long shot. I hate green. But as far as my diagrams are concerned, yeah, they're my favorite. So, as far as the labels are concerned, so, and you get to have your favorites as well. So don't worry about it. All right, we're gonna move that up here. Okay, router 2. All right, and as always, your diagrams will have IP addresses and so on and so on. Now, I am going to do that right now, actually. Oops, stop. Okay, and 192.168 that's fine. Okay, I knocked myself off the internet again this morning, doing the same mistake I did on the video, which I'm sure that's the one I uploaded, because one of them I did not upload. Okay, so let's actually make this a little bit bigger. Okay, let's bring this down here. Okay, and this is going to be. I'm tapping on the actual table again. I'm sorry. I'm just my energy's coming back, which is a good thing. So now I'm going to get rid of you and copy you both without the window key, but the control key. Okay, and let's move this up. Yoink. All right, and let's move this over. Now remember, if I want to move it faster, I just zoom out. Okay, so That's the it really amazes me that how many guys in our field do not have the skill of Visio. It's not that I took any special class. I mean, I learned it on my own, but like any skill over time, you get better at it. So now here's the key thing. Because we're using VMware, okay, our number one important thing is telling our link, okay, where it sits, okay. And now let's change this color. Let's make this. That'll work, okay. So now, and technically, I want this on the actual link itself, okay, as if they were like connected. Okay, so now, okay. This is everything that's in our diagram, okay? Now, we can do two things. We can just keep this diagram up here, okay? And then come over to Secure CRT. I'm so glad I installed it. I don't know why I didn't install that in the first place. And to be honest, really to be honest, I forgot I had it. So, I was sitting there looking on Van Dyke's site, saying how much does it cost? It's $120. If I get it, okay, I won't be able to get my, and you gotta understand something, guys. Okay, this thing is old. This thing is like 7.25, okay, and, Van Dyke, and yeah, so we're at, okay, this is May 8th, 2007. Do you have archives? Older versions? Not sure, but nonetheless, I mean, oh my god, the last time I bought this out of pocket, okay, this is because even when you're working in some contracts, okay, now with security being the way it is, I doubt if, okay, people are not purchasing this product, okay, as a default application for you to log into the devices. I mean, I would, but at the same time, okay, not everybody's like that, okay? It's SSH traffic, so it's still protected anyway, so why spend the extra money for it? Because from my perspective, you're an idiot if you don't. But idiot is such a harsh word. It really, I mean, it's protected by SSH, okay? All right, and the bottom line is, this is an expense, but it's only for your engineers. It's not like you're buying it for everybody in the company, okay? And especially if you're like a bank, trust me, they're not they're not wasting not $1 to make sure you don't have this program. All right, okay. Secure CRT is for that aspect of the extra security it has, but we're at 9 now. Now for my lab, who cares? Okay, all right, it still works. All right, so it's just the fact I forgot I had it. I was using putty, so when I went to actually download, I was like, you know what, forget it. I'll get my course later on, which I can't get yet because they're still working on why I can't even pay for it. Okay, so they're having issues on their end, and I'm really eager to start, guys. I'm really eager to start my security training, but you know what's funny? I should be worried about getting my Security Plus exam out of the way, but still, which is already paid for. I just gotta schedule it, and I might even do it today. So now, okay, what was I doing? Oh, okay, so we are going to go into VMware, okay, and instead of doing it with the VLANs, we are going to do this via virtual switches, which is so much more of a guarantee that I'm not going to have crosstalk, okay? And crosstalk is my biggest issue and my biggest concern with all my labs, okay? And I am not kidding, all right? So imagine having all your interfaces in your lab talking to every other interface, and you're pinging, and you're thinking that you're doing this magic configuration, and it's just because every damn interface is just on a single bus. All right, your configurations are not correct. You're not correct, and you have no clue. Everything's just working, okay? And we can't have that. So we got to have reality come to play where our interfaces are there. So now, okay, so now we're going to actually bring up our interfaces after we actually put these interfaces, G1 and G1, which means we come down here and take a look at our interfaces. So CSSR1 or router 1, okay, edit, and the first one is going to go into switch 1. And there you go. Boom. And now see our CSR2, okay, goes to switch 1. Okay? Now, we're not going to turn on number 2, okay? And if we go back, which is what I love about this, is when we go back to our configuration on our network side, you're going to see that SSR1. Now, it'd be nice if it's actually said which interface was sitting here, but it doesn't. So, oh well. All right. So now, okay, this is correct, but those interfaces are going to be shut down. And you know what? I'm going to move them out of home 1 just for cosmetic reasons. Okay, so let's go in here. And oh Lord, and we're gonna put this in switch 2. Come on, and put this in switch 2. Okay, so switch 2. Okay, so now we've already tested to make sure that there's no bleeding from interface 1 to interface. Where the hell did it go? Oh, okay. Interface 1 going to interface 2. Okay, on that same router. We're talking about CRS1 or CRS2. We've already tested that, so we know. Okay, whether it's VLAN sending the group, the switch group to VLAN to a particular VLAN, or just having a separate V switch. Okay, because that's what this is. All right. So remember, we have our properties here, where we can actually add a port group in our V switch here, making this V switch longer with every group that I add, or we can actually go over here and say add networking, okay, and then create a new V switch. And now, since we have a single V switch between interconnections, dude, I'm safe. Okay, I'm not worried about it at all. So now, okay, so let's go into Secure CRT, and first of all, let's go send command to all, okay, and show IP interface brief, okay, and first of all, are we actually at 14 font? And can I change the font of here? Otherwise, I guess you guys are going to have to squint. This is 14, I believe. Is it? Let's actually take a look real quick. Kind of looks kind of small, but keep in mind, I am at 1400, 1440p resolution, so that might be an issue too. So, appearance. Yeah, it's 14. Okay. All right. So now, why do I choose 14? 14 is big enough where the output will not start scrolling to the next line, meaning that it'll get cut off because it's so big, and then it'll continue on to the next line. If we go to 16, if the output is something like this long, see how this is doing it? IP interface brief, right? Okay, well, at 16, it's a lot more. Okay, so I try to keep everything within one line. And this could have been the fact that I didn't have the screen long enough anyway. But now, okay, so gigabit 2 is shut off, and we're going to just go in here. Doesn't matter, we're doing on the same on both routers, doesn't matter. Interface G2. Okay, shut down interface G1 IP address. Okay, so where are we at now? IP address 192.168.1.1.255.255.255. Now this is gonna put the same IP address on both of them, okay? But we're gonna go back up here on number 2 and change this to a 2. Okay? Alright, so do show IP interface brief. It says bad mask, and that is because you put in the wrong. Yeah, same thing here. So that, okay? So now, do show IP interface brief. Okay? Do show IP interface brief. Alright, so we are up and running, and now do ping 192.168.1.1. Okay, now remember, every time you do a first ping, okay, your first ping is always going to fail. Okay? Alright? Always. And the reason why is because during that time, that first ping is going to ping our time out while we are going through okay, I need an ARP entry for this IP address and build my ARP table. And that's the whole thing. So we're sending out a request. The request is coming back, and I'm building my ARP table within that split second. Okay, that's how fast these goddamn things communicate with each other. All right, and then the next 4 will come up and ping. So, you know, that ARP is always going to make your first ping fail, and after that, you're good to go. All right, so now, okay, so now we're going to go on both of these devices, and we're going to say a router, OSPF, and 1. Okay, now, if I do this, okay, okay, let me do it this way. Router OSPF. Okay, so process ID. Okay, process ID is a... Okay, like EIGRP. EIGRP and the number after that, that is an autonomous system number. Okay? RIP doesn't have this number at all, but again, we're not worrying about RIP, okay, in a lot of cases. But, and that's only because this is... we can honestly consider RIP as a legacy protocol from the perspective that people aren't using it. Okay, all right, and there is so many reasons why people don't use RIP, and I laugh at each one of them. Okay, because your opinion of it really is an opinion. All you do is repeating what other people are saying, and apparently, if you really knew RIP, okay, down to a detailed level, none of these problems that you're complaining about would actually be an issue. First of all, I don't have to have broadcast addresses. I can use multicast. Okay. Also, I don't have to have 30-second timers. Okay. I can change them to 5. All right. So, you know, it's like all these things. It's the concept that, yes, EIGRP is a lot easier, a lot faster. It has a backup route. Okay. All of these have valid things. But to act like RIP is so horrible, like, you know, you're an engineer and you're above RIP. Okay, guys, it's just another routing protocol, guys. Okay, all that extra crap is exactly what it is. It's just crap, and any expert in the networking field would have no problem using RIP, especially when they walk into a RIP environment, because it's just a routing protocol, and I know it. Okay, when I walk into a bank and I see frame relay all over the place, who do you think is going to be the only one that actually is comfortable with frame relay? Just like when I was in the NOC. Okay, nobody knew what free relay was, but I did because it was heavily part of my curriculum. All right, so I mean, I troubleshoot free relay like a boss. All right, and when I first started doing it in knock, I was like, wow, this shit really works. This studying really fucking works, man. Okay, so EIGRP, okay, has an autonomous system number, meaning that we have to have them match, okay, on both sides, okay, because I cannot create a EIGRP adjacency with an autonomous system of 1 with another autonomous system of 2, okay. They're not going to form an adjacency, all right. But with a router OSPF process ID, it's just a process, okay. It has no bearing on what the other router is running as a process ID, meaning that they don't have to match. Sorry, okay? So now, we're done. Okay, so now let's go into here. Okay, done. Now, let's shrink our board here, okay? So, now, I showed you how to do network 0000. So now what I'm going to do is I'm going to show you what normally happens in a industry standard from an engineering perspective, because this is more, how do I put this? It's, yes, it is more specific, okay? All right? Yes, you look more, okay, because network 0000 could be, considered kind of lazy from another engineer perspective. Who gives a shit, okay? The reality is, what it does is, in your configs, when you look at it, it is more specific, because how we're going to do this is we're going to say network 192.168.1.1, okay? The actual IP address of the interface. Now, what's next? Our wildcard, okay? Remember we talked about that? So, we're going to be specific. Now, I could say 0.0, oops, 0.0.0.255. That means anything that starts with 192.168.1, okay, we're going to enable OSPF on there. Now, here's the thing. How's that possible? Because I cannot have more than one interface on the same network. But if I have the subnet mask of that interface as a /30 instead of a /24, okay, and that means I'm going to have 4 IP addresses, all right, 2 of them are going to be valid, and that means also that if I put this actual command in here, that means every interface that begins with 192.168.1.0, blah, 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 blah. However, okay, you are working on a 9-blade switch, okay, all right, and there are interfaces everywhere, okay. Yeah, you kind of don't want to do it with the wildcards. You want to actually have every one of them, all zeros on a wildcard, and very specific to the interface itself. Now remember, before we did network 0 passive interface, meaning that you have to make an extra step to go in there and say no passive interface on a particular interface to enable that EIGRP on that interface or OSPF. Okay, but we're not doing that this time. We're doing it a different method. Okay, see, now you know why I taught it that way. So now, okay, now this is important. After you are telling OSPF the network interface that I want to enable OSPF, we also got to see what area is in. Okay, and we're going to start off with area 0, because remember, all right, everything must transit area 0, going from area to area. And in many cases, I have seen OSPF on a large scale only in Area 0. There's no other areas. Okay? So, don't be surprised if you see that. Okay? And now we're done. Okay? So now I'm going to go ahead and take this command. Okay. So we're going to display content. Okay? I like it better that way. Something you can't do with putty, which I think you can, but just it's like a bunch of steps you got to go through to make the menu. I never got it to work, by the way. Okay, and now we're going to go over here to 2 because that is 1.2. Okay? Now, we're going to wait. Show IP OSPF neighbors. Okay? Now, that's not good because that's not good at all. So what we're going to do is we're going to take a look at what's really going on here because we're stuck in two-way. Remember one of those ways that we're talking about that we can get stuck? That's not good. Okay, so now, remember, when we're stuck in two-way and it says the other, okay, what does that mean? All right? Do you see? God, I'm so sorry that I'm tapping on the table like this. You're going to have to bear with me until this energy is, gotten out of my system. It's nothing more than a sign of being getting better. But at the same time, I love my desk and I love banging on it. So, sorry. Now, and I don't realize I'm doing it. So, look how long OSPF took. Okay? Nowhere near the speed of EIGRP. Okay? We were even able for some time to actually look at the neighbor, okay, and look that I was stuck in a two-way state. And now we're in a full state. And now it says BDR. Let's go over here. And that says DR. Now, remember what the DR and the BDR does. Okay? We got two IP addresses, 224.0.0.5 and that's 6. Okay? One talks to the DR and one talks to all the other routers. Okay? So it's not like we're having one, which originally I had said, which I was wrong. Okay? Which it's not going to be the first time or the last. But what I will promise you, if I am wrong, I will catch it. In most cases, sometimes I won't. And if you mention it, I will go back and research it, and I will recorrect that mistake. Now, with that being said, it's not like we're having one multicast address talk to the BDR, the DR, and the BDR, which I had said prior. That's not the case. One is going to be all the other routers, and one is the DR. And the case about this is, this means I don't have router to router to router to router to router going back and forth, back and forth, back and forth, back and forth. Okay, I'm going, when there's an update, send it to the DR. Then the DR sends it to all the routers. That eliminates the bandwidth. Do you understand how that works? Otherwise, every router is going to be sending every information to his neighbor, and it's going to be a pain in the butt. However, the thing about this is, this concept should not be concerned with a point-to-point link. What's a point-to-point link? On router 1's perspective, while he sends traffic down G1, the only other person that's going to receive that traffic is what? Router 2 G1. Okay? It's point to point. There's nobody else on there. Okay? Now, if I have 15 routers hooked up to a switch, now you can see, okay, everybody's on the same subnet. Okay, everybody has an IP address of .1, .2, .3, all the way up to 15. Okay, yeah, you got 15 routers sitting on a subnet. Okay, yeah, you might want to have a DR and a BDR. Okay, so DR and BDR traffic on a point-to-point link is pointless. So now let's go take a look at this. Show IP OSPF interfaces. Okay, and we're going to say G1. Okay, so I'm doing it again. Okay, here we go. Our network type. Now, if we have 15 routers on a broadcast network or on a subnet, that would make sense. But because this is a point-to-point link, we really should change. We really should change the network type. IP OSPF network type. Point to point. This is not semantics. This is real shit. Okay? Meaning that, okay, this should be your regular practice. Okay? Now, you gotta understand, with OSPF, remember, our hello timers and dead timers have to be the same, okay? So even though this actually did do a full adjacency again, okay, we're still going to go back and change the actual point-to-point on this as well. So, IP OSPF network, point-to-point, okay? And now do show IP OSPF, OSPF adjacency. Neighbors, sorry. So show IP OSPF neighbors. Okay, so now you know that the DR and the BDR information is not in there on both of these devices. Show IP OSPF neighbor. Okay, so I'm not worrying about logging console because I actually put that command in there. I don't know why it's not working, but you know, I'm so used to hitting the tab key to come back to the where I was left typing from. So we'll just do it that way. So as you see now, OSPF is up and running now. In our information here, let's take a look at show IP OS. Oh my God, PF database. Okay. Now remember those LSA types? Matter of fact, let's go back to them. Yoink. Okay, so here we go. Remember our type 1s. They're called router LSAs, but in our table, it doesn't say router LSA. It says router link states. Okay, and as we start building each one of these, okay, all right, because the next one we're going to end up doing is putting it on a subnet so you can actually see what the type 2s look like, okay, all right, which are going to be the network LSAs, all right, and with the router LSAs, okay, so you're going to start seeing how this database is built. If you just go out and do a full-scale topology with OSPF and don't do it in this manner that we're doing, you're going to be lost. Because you're going to be like, well, where's my summary addresses? Because it doesn't say summary, does it? I mean, I don't know. Okay? We'll find out when that table gets built. Okay? But it's definitely not going to say LSA type 3s. So you're like, what the hell? Alright? So, okay? So now, so first of all, we got to understand what's happening here. Okay? In our database, we have an IP address and this thing here. Now, check this out. Because those IP addresses are the same. And the advanced router is the same. Okay, and the link ID. So we're going to go in here. Config T. Router OSPF. 1. Router ID. And I'm just going to say 1.1.1.1. Done. Now, reload or use clear IP OSPF process for this take effect. Gotta love when the router tells us what to do. Okay, so right now I'm gonna change this over here. Okay, and router OSPF, router ID, 2. Done. And I'm going to clear this on both routers. Okay? Clear IP OSPF process. And yes. Okay. So now we have bounced our adjacencies. Okay? And now I'm going to say show IP OSPF database. Look at that. Look at that. Okay? It changed both of them. Pretty cool, huh? Alright? So our router ID is what is being utilized in this database, not the IP address. That's why it's very crucial for me to show you that. And the router ID is being chosen because of the highest IP address that is on all our links. Okay? Loopback address is first. So if I had a loopback address of 1.1.1.1, that would become the router ID. Alright, unless my memory does not serve me correctly. I believe it's the loopback address and then the highest IP address. Alright, but then again, do your own research. Okay? So now this table, if I assign my router IDs in some type of standard of my network and in my organization, which means every company is going to be different, okay? All right, I know what 1.1.1.1 is. I know what 2.2.2.2 is, okay? And I'll be able to see my database all across the board. Now, from a database perspective, this is very small, okay? But look at what we're looking at. We have a link ID and a router ID, okay? And let's take a look at our show IP OSPF interface G1. I can just say interfaces and it'll just list all of them, okay? So keep in mind that the database is giving you information on the link, but the interface has a lot of information, like, guess what? The router ID, the point-to-point type, the cost of the link, okay? All right? Very important stuff. So now, show IP OSPF, okay? And let's take a look at events. I think it was in events. Just our events. Which is pretty cool if you want to go through there and take a look at that. Because look, we got an election of a DR, the BDR, all that stuff. The events of going through our stages. And this is a very good command for troubleshooting. Okay? Show IP OSPF. Neighbor. We did neighbor before. Okay. Sham links. I haven't heard that in a while. I think sham links are for lower links as far as speed is concerned. I can't remember. but I believe that's what it is. It's kind of like a backup link. Statistics. Okay, which ain't really giving us much. Okay, all right. And I believe still IP. We're gonna say No, that's OSPF version 3. Okay. I think that's all the information that we need as far as our basic commands. Okay? Alright? And that's pretty much it. So, first of all, we created an adjacency. We got to give OSPF some time. Okay? Alright? And keep in mind that when you're going across the United States or across the world, it's your time really isn't that much as far as waiting for OSPF to go through. But OSPF as show IP OSPF events. Since we started this, we've already had 200 events. Okay, all right. We even see it here, like G11 changes from down to waiting. Okay, and obviously, okay, this is 1354, 34, and this is 35. So this is the very first event that happened, and it went from down to a waiting state. Okay, all right, we got syncing going on here. Okay, all right, we're going through our init stages, our two-way stage, our down to init. Okay, all right, all this stuff. Oh, you thought I was joking when we went through all that stuff. You thought I was just giving you information that wasn't necessary. No, guys, this like I said, OSPF is a very complicated protocol. Okay, and if I had to choose a protocol that has more of a complexity to it, okay, to make you scratch your head, it would be BGP with MPLS. Okay, but hey, I'm not a service provider. I'm an enterprise guy, so not my cup of tea. Not my cup of tea. Even though maybe one day I will go down that path, but right now I'm not interested in internet provider. I am interested in security, so that is my path. So now, okay, just look at all these events. Okay. So yeah, OSPF takes some time for the adjacencies to come up. Okay, look, we got our exchange to X start, two-way to X start. Okay, all right, yeah, we got a lot of stuff going on. All right, so that previous lesson had its validity, had its purpose. Okay, and you got to see the database and there, and from from there we're going to actually grow our topology into something bigger. But for now, be strong, be determined, be Cisco.